So here guys, I want us to focus on this question here. This question is about the cosine rule. So this paper here, it said in the figure below, the acute angle triangle ABC is drawn having C at the origin. So here's C at the origin, and then the question wants us to prove that C squared is equals to all that, and this is the cosine rule, right? This is worth 6 marks, and then I actually wrote this question here so that I can have enough space for me to make my construction and solve the proof here, right? So the first thing we want to do, remember, this is 6 marks. Let me write it here. This is 6 marks. The first thing you want to do, you want to create your height. So here's the height, and you want your height to be perpendicular to the line AC, right? Afterwards, label the height H. It makes things easier. And then the end point of the height there, we want to give it the coordinate, because if that's where the line now, this line of the height touches the line CA. So we'll call this BD, right? And then afterwards, you want to give everything a coordinate. So the coordinate that starts at C, the coordinate at C is 0 and 0, because obviously this is at the origin, right? And then the coordinates for B, the thing is we don't know them. So I'll call this X at B, and I'll call this Y at B, this way, right? And then afterwards, I'll get to the coordinate of A. This one is more interesting. Coordinates of D, basically I'm saying here, B and D, they share the same X value, right? Which means the distance from here is the same as the distance from here to there. So for D, I'll call this X at B, and then the Y value, because this is at the Y-intercept, at the X-intercept, I'll call the Y value to be 0, right? So these are the coordinates of D here. Now, coordinates of A in this case, let's put it this way. Coordinates of A, first of all, I know that the Y value is 0. Why? Because this thing is happening at the X-intercept. And now for the X value, I look at the concept of the sides. Now let me label all the sides. This side here, it's opposite to the angle C. So this side will be called the small letter C. And then this side, it's opposite to the letter A, or the vertex A. So I'll call this side small letter A. This whole side now, from C up until A, it's opposite to the vertex B. So I'll call this whole side, which means from here up until there, that length, it's B, right? So which means now my X value here, it's B, because we are speaking about the distance from here up until there being B, right? So I gave everything, I gave every vertex a coordinate there, I gave every side a label, and I constructed the height. That's what I have. So now, what I want to do, I want to work with this angle. Why? Because I'm looking for the side that is opposite to that angle. And remember the cosine rule, it needs me to use the side, the angle for the side that I'm looking for. So let's get to it. Here, I'll start by looking for the sine of this angle here. So I'm saying the sine of angle C is equals to, the sine compares what? It compares the opposite over the hypotenuse. So sine C is equals to H over the hypotenuse, which is A. In which triangle? In this triangle BCD. I hope you see that. So now, the thing with H now, I want to write it properly here. So this thing is going to take some time from my side, because I want to make sure that you understand this part. The height here, the distance from here up until there, it's the Y value of this coordinate. What is the Y value of this coordinate? That is Y at B. So the height here, I'll replace it with Y at B over A, right? And then afterwards, I want to make Y at B the subject of the formula. Making this the subject of the formula, I'll have to multiply both sides with A. So I'm multiplying this side with A, and then I'm multiplying this side with A. Then this one and this one eventually cancel out. I'm only left with Y at B is equals to this part here, which is A sine C, right? So now, once I get to this part, I achieved a small objective for this cosine rule. The first step is perfect for me. Now I want to get to the second step now. The second step, I want to work with the cosine of the very same angle. I worked with the sine of this angle. Now I want to work with the cosine of the very same angle. So here I'm going to say the cosine of C. The cosine of C gives me what? It gives me the distance from here to there, right? What is the distance from here to there? It is the value of the x coordinated d. The x coordinated d, it's this one, which is x at b all over the hypotenuse. What is the hypotenuse? It's a. Afterwards, I want to make x at b the subject of the formula. So I multiply both sides with a, this side with a, and this side with a, right? Afterwards, I'm going to have what? This will cancel that. I'll be left with x at b is equals to a, the cosine of c. And then now here, I achieved another objective for myself here. Let's highlight this part. Beautiful. So from here, the next part is what? The next part is me now looking for the distance formula. Remember now the cosine rule wants me to look for the distance of C. What is C? C, it's B, AB. Let's call it AB. You see that? So let's use the distance formula to do that. So the distance formula says AB squared is equals to, right? It says AB squared is equals to x at A minus x at B. We square all that plus y at A minus y at B squared. That's what the distance formula says, right? So such that now I'm going to have, let's substitute here. AB it's the same as what? It's the same as C. So instead of saying AB, I'll say C squared. You see that? So some things are adding up there. And then for x at A, I substitute x at A. What is my x at A? I'll go to the coordinate of A. My x there was B, so I put B here. Minus, and then I'll go to x at B and see what it is. X at B, I have it here highlighted. You see that in pink. X at B was A cosine C, so I have A, the cosine of C. And then square that, plus my y at A, I'll look for my y at A. My y at A was 0, minus my y at B. What was my y at B? Here, A sine C. And then we square that. So these things here, the reason we made them like this, we wanted to substitute them into the distance formula now. So moving on, I have C squared is equals to, this part here basically means I must write this bracket twice. So I'll take the longer route here so that you get it, right? So I'll say B minus A cosine of C. I write the bracket twice, which is B minus A cosine of C. So this squared here it appears now. And then there's a plus, so here's a plus here. And then I have 0 minus A sine C. Inside the brackets, I'll be left with what? Negative A sine C all squared. We good? So this is where I am now. Now I'm just left with solving all these things algebraically. So I have C squared is equals to, I FOIL these two brackets. So first term and first term, they give me B squared. Outer terms, which is A cos C, negative A cos C, and B, they give me negative A B cos C. The inner terms give me what? Negative A B cos C. The last terms give me what? Negative and negative gives me a positive. A and A, it gives me A squared. Cos C and cos C, they give me the square cosine of C. Right, so these two brackets, when I FOIL them, I get that. So here's a plus here. I put a plus. And then when I say negative squared, it's what? It becomes a positive. A sine C squared, it becomes what? It becomes A squared sine squared C. Hope we're good there. This is now algebra. So here I have C squared is equals to, and then here, I'm going to take B squared. It has no like term, so it stays like that. It's B squared. This one and this one are like terms. I add them together, I'll get negative 2AB, the cosine of C, right? And then here I have plus a squared cos squared c. And then here I have plus a squared sine squared c. So I hope you see what's happening here. So afterwards, now I'm at this step here. Looking at this step, I see now that here, let me use a red pen. I see now that here, something can be done here. First things first, I see that I have like terms. Not like terms, common factors, sorry. I see that I have common factors. The common factor here is a squared and here it's a squared. So I want to take that one out. So I have b squared minus 2ab, the cosine of c. Cosine of c, will be good. Plus a squared and a squared, that's the common factor. I take it out and I leave the rest inside the brackets. Sine squared c. Now, and then when I look at this one now, this is a trig identity. This trig identity says if I have the square cosine plus the square sine of the same angle, this is the same as 1. So which means here, everything here inside the bracket is 1. And then I have a squared plus 2ab cos c minus here, and then the b squared is equals to c squared there. So this is what I have now, right? We are about to finish now, guys. And then afterwards, from this point here, I'm going to take this one. When I multiply this and this, it's the same as 1. So it's like this doesn't exist now, because when I multiply a with 1, it stays as a squared here, right? So I'll take this now and transpose it here, closer to b, right? So which means I have a squared is equals to b squared. When this one comes here, it's the a squared here, and I have the minus 2ab, the cosine of c. So at this point now, the cosine rule has been proven the way that we wanted. I hope that is good for you.